Good day, folks. Welcome to Pride's Mind Academy, where we bring brilliance to every lesson. In today's video, we're going to be looking at two questions, all right? Question 12 as well as question 13, respectively. So, yes. Now, let me try to zoom out that for us. Question 13 says to us, three compounds are used to investigate one of the factors that influence boiling point. This is our dependent factor, okay? Dependent factor. Okay, the results obtained are shown in the table below. We have butane, propan, all ethanoic acid. Can you see all of them are of different homologous series? Okay, this one has London forces. This one has one side of hydrogen bond. This one has two sides of hydrogen bond, right? Then we can see here, sorry, in one investigation, the boiling points of B and C are compared. Okay, is this a fair comparison? Write down yes or no. Yes or no. Refer to the data and give a reason for that. First thing first, are they of the same homologous series? No. Okay, sharp. First independent fact. Are they straight chains? No. Let's look at their molar mass. Molecular mass, it is 58 and 60. It is comparable because it does not necessarily have to be the same. 50 and 60 are not necessarily far, okay? But now they are of comparable molecular mass. The question is, how many independent factors do we have? We have chain length. Chain length, okay, we do not need that. Molecular mass is covered that for us. Butane, propan-1-all, okay? Different homologous series, no branching, chain length, not the same, but molecular mass. This is a fair comparison. I want to believe it is a fair comparison. Really? Yes. Actually, they are not comparing between A and B, man. They are comparing between B and C. The purpose of not reading very well. Between B and C, the answer is yes. Why? They have the same molecular mass. Oh, sorry. They have the same molecular mass or molecular size. Okay. Then now when we move on now, they say write down the independent variable for this investigation. For this investigation, the dependent variable, it is homologous series. Why am I saying homologous series or functional group or type of intermolecular forces? They have different type of intermolecular forces from that to there, right? This one has a London force, this one has alcohol one side, this one has hydrogen bond one side, this one has hydrogen bond two sides. So the type of independent here, it cannot be chain length. Chain length occurs within the same homologous series. Branching also occurs within the same homologous series. So here you can say a homologous series, functional group, whatever, okay? So you can say it is functional group, or you can also say homologous series. Okay, yes. Which one of the following, which one of the compounds A, B, or C will have the highest vapor pressure? The one with the highest vapor pressure will have the what? The lowest boiling point. Which one has the lowest boiling point? It is butane. So the answer it is A. Give a reason for your answer. It has the lowest boiling point. How interesting is that? How easy is that also? Okay. Then 12.3, 12.3 says, refer to the intermolecular forces present in each and fully explain the trend in the boiling points as shown. Very, very interesting question that I like thereof. You will say 12.3 for 5 marks. For 5 marks is you identifying the intermolecular forces first, 3 marks. Okay. First thing first, you can say compound A Okay. Compound A has London forces, right? It has London forces. B, compound B has one side of hydrogen bonding, right? One side of hydrogen bonding. What is B? What is B? B, it is propan alcohol, okay? Then compound C has two sides of what? Hydrogen bonding. How interesting is that? Then what? We now need to mention which one has the higher intermolecular forces, okay? Which one has the strongest intermolecular forces, okay? So we know that we'll say, which one? Compound C, or what did I say? Or fully explain the trend in boiling point, or from A to C again. Okay, just say here from A to C. A to C. What happens? The strength of intermolecular force molecular forces increase from compound A to compound C. Right? Why? Can you see? Now we are moving from London force to one side of hydrogen bond to two sides of hydrogen bond. The last step, you need to say more energy is required to overcome intermolecular forces Stop using IMF here, auto force. You will get it incorrect. More energy is required to overcome intermolecular forces of compound C than in the other two compounds. How interesting is that? 5 marks, very, very nice. What are you now telling us? Okay, you realize that now, and this one has London forces, this one has one side of hydrogen bond, okay? Then the other one has two sides of hydrogen bonds. Then telling us the strength increases from A to C. Now more energy is required to overcome those of B. How easy 5 marks is that? Can you see now? Sorry. Butane 1-ol, which has 4 carbons, and propan 1-ol, which has 3 carbons. Which one between butane 1-ol or propan 1-ol has a higher boiling point? It should be butane 1-ol, right? Why? It has the longer chain length. It has a longer chain. Give a reason. Reason is longer chain length. Okay, yes. Or larger molecular size, or stronger intermolecular force, or yeah, whatever. But it has a longer chain length, all right? Yes. Let's move on to this one. Number 13. Define boiling point. The temperature at which the vapor pressure of a liquid is equal to the atmospheric pressure. How interesting is that? The boiling point of 5 organic compounds, P, Q, R, and S, and T are studied. Yo. Compound, okay. The boiling point of Q, R, and S, let me try to do this. Q, R, and S are compared. Give a reason why this is a fair comparison. So they are telling you it is fair. Why? Butane, pentane, hexane. So here what this has 2 branches, this has 1 branch, this has 0 branch, but they are of the same homologous series. I get, and they have the same molecular formula, which is C6H14. You can count them. You can draw the structures and count them. So now it is fair. Why is it a fair comparison? Why? Because now they have the same molecular formula, they have the same molecular mass. Again, yes, they have the same molecular mass. Molecular mass or molecular formula. Again, or they have the same molecular formula. How interesting is that? Now we move on to the next question. The boiling point of Q, R, and S are given in the are given below, not necessarily in correct order. Very, very interesting. Which one of the following 3 boiling points is most likely to become the boiling point of R? Explain the answer. R, which one is R? Remember, you're comparing between Q, R, and S. Q, R, and S. So now of R, this one. Can you see? Remember the independent variable here. The independent variable here, it is branching, right? So as we go down, the branching decreases. So it means now the boiling point increases as you go down, okay? But can you see, R, it is between Q and S. So its boiling point should be between. So its boiling point should be between. So its boiling point, it is 55 degrees. Why? Let us be in a position of using appropriate reason for 13.3. The first mark is you saying now it is 55 degrees Celsius. Then use appropriate reason now and support your answer. Okay? Support your answer. Now you need to compare R with respect to Q and S. I repeat, you need to compare R with respect to Q and S. Okay? So what will you say? You will say, where is that? Let me go down. You will say compound R is more branched than compound S. Okay? But is less branched than compound Q. Very first one. The second one you need to say therefore. Okay? You need to tell us that, okay, therefore now what happens? The intermolecular forces needed thereof, or rather the strength of intermolecular forces. You'll say compound R has, remember, if you are more branched than the R, it means now you have weaker intermolecular forces. So since well compound R is branched more than S, okay? Compound R is branched more than S. It means now compound R, okay, you'll say the strength of intermolecular forces of compound R are stronger than the one that is more branched than it. Than compound, which one is branched more than it? So Q is branched more than R, okay? So now it means the strength of intermolecular forces of R are stronger than compound Q. Why? Because the one that is more branched has weaker intermolecular forces, right? But weaker intermolecular forces. Okay, the strength of intermolecular forces of compound R are stronger than compound Q, but weaker than those of compound S. Why? Because compound S has the longest chain length and it is less branched. First mark here, second mark here. The third mark is you telling us therefore, or remember the first mark here, you got it from say 55 degrees. And I don't know if you say 49.7 degrees where the mark you'll get, will apply negative marking. So then you say now more energy is required to overcome intermolecular forces of R than what? Than Q, but what? Okay. And more energy is required to overcome intermolecular forces of R than Q, and less energy is required to overcome intermolecular forces of R than S. So this tells you, okay, R has intermolecular forces that are greater than Q, but that are less than S. So R, it is between what? So R, it is between what? S and Q. So hence we said now R has the one that has the middle, which is 55. If you said 49 was your answer, 49.7 was your answer, you're gonna get everything incorrect. We apply negative marking. Then they tell us now, they say a mixture of equal P and T. P, what is P? P pentanal and T pentanal, okay, is placed in a flask and heated to a temperature below their boiling points. Assume that no reaction or condensation takes place. The vapor produces the vapor produced is collected in syringe. Okay, so now they are collecting the vapor. Okay, they are collecting the vapor. Okay, so which one will have the highest vapor? The one that has a lower boiling point, right? So P and T. P, it is what? P, it is pentanal, which is dipole, okay, pentanal. T, it is what? Pentanal, 1-all. So which one of the following will have the greatest amount in the syringe? The greatest amount of what? Greatest amount of what? Of vapor. It will be P. Okay. Why is it going to be P? Because remember, I'm answering this question now. Explain the answer in 13.4.1. Why are we saying it is P? Okay. Remember now, P has dipole forces. Right? Then and T has what? T has hydrogen bonding. Hydrogen bonding And they say referring to the type and strength only. Hydrogen bonding. This is the type. The strength, therefore, we know that P has weaker intermolecular force than T. Okay. Or you can say T has stronger intermolecular forces than P. Then what will happen? Therefore, I know the one that has stronger intermolecular forces. The one that has stronger intermolecular forces will have a what? A higher boiling point. And the one that has a higher boiling point has a lower vapor pressure. Okay? Yes. But the one that has weaker intermolecular force will have what? Will have weaker boiling point, but will have what? Higher vapor pressure. Hence, now we are saying P will have a greater amount of vapor pressure in the off. Okay? Yes. So that is it. That's all from me. I hope you enjoyed. So yeah, if you enjoyed, please watch other videos. Thank you.